And then I woke up and I was like, oh yeah, that's not a real thing.
That's funny. 7 out of 300. That's wild.
Number, yeah.
Going to sleep after 11 is super late for me. Like, I prefer to go to bed.
7 out of 300. All right, so today we're going to talk about something very, very easy. So we're just going to stick through, fighting through. But there is a lot of AP element to it. Unfortunately, I have to teach Chua a test on this particular part. On a lot of cases, I have to teach Chua's the AP part because that's a final exam you have to take care of. So what I'm going to do is I'm going to talk about what is finding extremas. So finding extremas within intervals and within closed interval. A and B. So what I mean by closed is going to be, including the value. It has to be a solid circle in order to work. So this is a close. Every time I talk about that's a closed circles. With that being said, you say, okay, well, hey, let's look for this. But let's first understand what the heck is extrema mean. Extrema basically is the highest point within the interval. Or the lowest points. But we have another name for that. It's going to be absolute maximum and absolute minimum. Okay, so they are the highest point. So this is the highest and this is the lowest. Okay. So for example, if I were to give you a graph and this some type of graph, let's just say I have an A, I have a B here. I have some type of graph like this and I go down lower and I go up higher, I go down lower and I go down here, the highest at B. At this point, since the function go down and up, this is called a relative minimum. And this point is called a relative max and relative min. Hopefully you guys okay with it. Now, there was an endpoint there. There was an endpoint here. Well, what if that endpoint is higher than relative max? Well, this point is called a absolute maximum. Although it's not going up or going down, but here we just care about what is highest. So highest is called absolute maximum. Now, can relative min or max be absolute? Yes. This one here is absolute minimum. Because this is not only the lowest point, it's also the lowest point of the interval. It's not just a relative min. Are we okay here? With that being said, that you have the situations here and you have the understanding that extrema. So we also call this extrema. So there are two extrema. Okay, you can have a you can have just pretty much one maximum and one absolute minimum. Sometimes you can have couple. Depends on if you got a parabola in the two highest point. So sometimes you can have that, but that's no big deal. Okay, with that being said, how to find the absolute, or how to find the extrema within the interval? A and B. How do I find it? Well, first thing is always find the critical number. Why we need to find critical number? Well, think about it. This part is C. This part is C. Because all maximum minimum are critical numbers. So you know that is the candidate for the highest value and lowest value. Does that make sense? But don't forget, at this case, they now only have 3 candidates. There was 2 more candidates. One at the endpoint and the other one at another endpoint. So there are total 5 candidates in this graph. Other graph might be 4, other graph might be 3. And so find critical numbers. And it really depends on what the function is. It may be numbers. Second, you evaluate the critical number. What do I mean by that? Plug in where? The derivative or original? Original functions, right? Plug in original function and solve for y, right? Solve for y, not the derivative. Solve for y. And third thing is evaluate the endpoint, because you don't know if your endpoint are higher. So endpoints, usually they are 2. Actually, they are always 2. Evaluate the endpoints. The 4 is compare with the table. What do you mean by table? Table means justification on AP exam. That usually means 1 point. So justification give you 1 point. So if you're able to justify, they give you a 1 point. So you just compare with the table and states the min and max, absolute min and max. Okay, just state them. What is my table? Table is a t-chart. X, Y, or X, f of X, sorry. Usually you have a endpoints. So in this case, some type of endpoint, maybe 1 to maybe 5, so endpoints. And you're gonna plug into original function, get those values. And you compare which one's highest and which one's lowest. That's the bestest way. So depending on how many critical value you have to do. Are we okay here? Yes.
Before, with the table and
So you're gonna list down on the table.
yes, and state the what?
State the absolute max and absolute min. So you got absolute max and absolute min can happen within the interval. So it's just basically highest point. But those are the candidate. The critical number are the candidate. And that candidate is gonna be the first place you look at. So, you know, a candidate, it could be like, all right. So what will be the question? Here's a question for me. Is f of x is equal to 3x to the 4th minus 4x to the 3rd and between -1 to 2? So between -1 to 2, you want to find out the absolute maximum and absolute minimum. And we're going to talk about in a second, also talk about where and value. So give me a second, we're going to talk about that later. So I'll let you work it out. Find a critical number plug in the original equation, find the y value, find each y value to decide which one's highest, which one's lowest.
Sometimes the highs and lows, you can just plug in numbers between them and putting them. Can you please scroll up for a second? At the graph. Okay, thank you.
You all right?
Yeah.
Gabby, okay?
Yeah, I finished. I'm doing that now.
Huh?
I finished the test corrections. I'm doing that.
Okay. You're bored. I will take a derivative, right? So that'd be 12x to the third minus what? 12x squared?
Yes.
And can I factor out 12x squared?
Mhm.
That's going to be x minus 1. So that's x equal to 0, x equal to 1. So then you have to test -1, 0, 1, and 2. And you test them, see what happened. And I think if I plug in -1, I will get something like 7. I think. Right? What happened if I plug in 0? What happened if I plug in 1? -1. And if I plug in 2, is 2 to the 4 is 16. 16 to the 3 is 48. 48 minus 32, so it's 16. So this one is absolute maximum, and this is absolute minimum. And that's one AP exam you want. So they say, tell you what's absolute minimum. You can give it coordinates. You can say that's, oops, that's 1, -1, or you can say x equal to 1, and they can say 2 and 16. But if they ask you absolute minimum value, that means value means the y value. That means the output. So the way kind of think about is this, is I always told students yu. So if something is yu, that means y value. So in this case, y value, absolute minimum value is going to be -1. And absolute maximum value, again, is a yu. So that's equal to 16. So just equal to one number, the y value, the output. It doesn't matter. So if I ask you, like, what is the height of tallest person here? So you're not gonna say it's Tyson. I really don't give a shit. Who is it? I just says which person are the tallest. So Tyson is the tallest, and you're gonna tell me he is 6'3". You don't care about is Tyson, you just care about 6'3". That's the value. I only want a value, right? So those are the things that you should pay attention to. Yeah. Does that make sense? Pretty easy, pretty straightforward. They're not something complex. Sometimes they do have something complex like this. The problem is a lot of people cannot find a critical number in this case. So 3x to the 2/3. So this one, so far, only one student claimed that they got it right so far, is to finding critical number. Critical numbers. So they are, I don't need you to find out the absolute maximum and minimum. I just want you to find the critical numbers on this one. Now it turns out, there were some small things that we do need to talk about. That is gonna be absolute minimum. So more likely you'll do it wrong, and it's okay.
So you said that the vertical asymptote is not a critical number?
It is a vertical. Right here that doesn't have a vertical asymptote. Right here you got a something that is like here. This 2/3 power is called even over odd power, and that usually means cusp. So that means there is a cusp in this case. So it's a cusp warning here.
Oh, what's it called? Is it the number?
It's even power over odd power. Anything even to odd power is gonna have a cusp, or at least x. X to the even over odd power. Not odd over odd power, only even to odd power.
So horizontal asymptote is when you put the numerator equal to 0?
Horizontal tangent is a numerator of derivative equal to 0. Vertical tangent is the derivative of the denominator equal to 0.
So it's vertical tangent, not a critical number?
A vertical tangent is also a critical number because a critical number can be 0 or undefined.
Well, what were you trying to do earlier?
Yeah, we're going to talk about those a small difference. So previous case that we talk about this case here, right? This case, you see the original function has a denominator, and you turn out you got x equal to 1/2. Now, if you plug in the original function, it's not even a number that exists in the original function because it actually gives you something over 0. So it's actually undefined. So it's actually not counted as a critical numbers. But you still test them later on. If you do a number line test, you still test them. So this one is not included because original domain doesn't require it. Now here in particular is if you look at the original function, doesn't have any denominator in this case. It does not have any denominator. So even you find that, it's probably okay. So now I'm going to take a derivative of this. It's going to be 2 minus 2 over 3 times x to the negative 1 over 3rd. So that's equal to 2 minus 2x to the negative 1 over 3rd. If you set this equal to 0, you're going to only find one critical number. But it turns out there are two. How do I find the second one? Well, if you have this fraction, my tendency is always set this to this, to fraction. Because if you have fraction, that means you combine this two. So that means I need to multiply top and bottom by x to the 1/3 and the x to the 1/3. So it'll be 2x to the 1/3 minus 2 over x to the 1/3. So that's equal to f prime x. Now, if you pay attention, now you have numerator and denominator. You have two critical numbers instead of one. So 2x to the 1/3 minus 2 equal to 0. X to the 1/3 is equal to 1. You cube root both sides. So x equal to 1. So x to the 1/3 equal to 0. You cube root both sides, x equal to 0. There are two critical numbers. Yeah, you got one of them. Very good. But the second one is harder to find, and usually student does forget them. But luckily they don't test that on AP exam. At least I don't think so. But if they do, hopefully you got it. But I don't think they will. But still, it's a very interesting thing because I hear you actually have a two critical number. Now I'm gonna go ahead and plug in original function for you because I don't want to stuck in this moment for a long time because I want to talk about Rolle's theorem. -1 to 3. So 3 here. So we got a 0 and 1. So if I plug in this value, is -5, 0, -1, and -0.24, I think. So this end up to be absolute min, and this becomes absolute max. Now, if I ask you absolute minimum value, it's going to be -5. Absolute max is going to be 0. So yeah, 0 can be your max even though it's a 0. Because the highest value compare, 0 is higher than all negative number.
What did you say for 3? Is that 0.24?
0.24 if you plug in a calculator. It's very hard to plug in that one. So those are the special cases. I do have 14 minutes to talk about rule theorem. You're going to have a whole worksheet about rule theorem. The rule theorem is not different than before. Rule theorem is about the way it kind of talk about rule theorem, the way I kind of think about it is this.
Wait, so please go just a second. Okay.
What's your homework gonna be?
On rules value theorem and the finding the number intervals.
Extrema, find that.
Huh?
The Extrema? You have to do
Yep.
that for homework?
And you have to find the rules theorem. Rules theorem is a multiple choice, but all the multiple choice is very, very good questions. So let's talk about the rules theorem. Rules. So I want to change that this handwriting a little bit, kind of rules. So it's R, LL, and I'm going to leave the O right here, so it kind of help you to see that there is a 0 there, and that O means 0. So rules theorem. So Michael Rules is a mathematician. He didn't believe in calculus. He actually hates calculus. When Newton is flourished, and he's like, oh yeah, screw the Newton. I don't believe in Newton because he just a snobby man or whatever. I don't know what you think. So he really don't like the idea of calculus. So he basically he was like one of the biggest critic of Isaac Newton. But later on, he was a critic so much, and he started really into like Newton's work and Lembed's work. So he kind of see that there's a usefulness in calculus. So later on in life, he actually agree with the calculus, which is that's very, very interesting that he kind of changes perspective throughout the way. So he's willing to change. Rules theorem is very, very intuitive. It's not something very difficult. So here we're going to talk about the condition in order for rules theorem to work. So condition. Usually they have also the same condition. You're going to see that f of x must be continuous. And between A and B. So that means you cannot have open circle at the endpoint. And that must be close, right? That must be close. Second condition is f of x must be differentiable. So be differentiable, be differentiable. And we already talked about those definition of differentiable. Now, here's a small thing I want you to pay attention here. Okay. It's a parenthesis A, comma B. But why do we use parenthesis though? Why do you think we need to use parentheses? Yes.
A and B are not included.
Why? Why is not included?
I don't know. I thought you were just asking what it means.
So this one's open. The reason why they are open is because the function is never differentiable at the endpoints. That's one of the things not differentiable at endpoints. So it's not differentiable at endpoint. Okay. Third, the third condition is actually interesting. F of A equal to F of B. So F of A equal to F of B, that's actually a very interesting one. Why did he list that? Because he kind of says, oh, and the result is this. They say F prime of C is equal to 0. So at least one C where F prime of C is equal to 0. And you're like, you know what? That's very, very silly. But yeah, he did that. That's a very, very, that was a very, very important part of his theorem. And you're going to be like, why is this theorem so important? Because this is a stepping stone of another theorem. So mathematicians, they copy work from each other. They steal from each other, right? They say, oh, I like your idea, so they kind of copy it. And it's kind of like everything in society, anything, they copy each other, right? Everybody's copying from Tesla right now to build electric cars, or Apple is copying Tesla right now. They are building Apple cars. So, um, yeah, so everybody is stealing each other people's work. So really, this is a very first original work by Rawls. Rawls kind of create a foundation for the future for other people to kind of take his idea. So why this is important though is because later we have a mean value theorem. And mean value theorem, the Lagrange, which is the mathematician, kind of find out the mean value theorem. He kind of stole it in a way that's pretty interesting. He says, do I need all those conditions? I might not need all those conditions. If I don't have all those conditions, what will happen, right? So the MVT kind of change. But first of all, we're going to talk about continuous. So remember, continuous, majority, pretty much all polynomial, all continuous, all polynomial. It didn't matter what. Sine of x, cosine of x, e to the x. It's always continuous. Yeah, all form of polynomial are continuous. Sine of x, cosine of x, e to the x. The only time is not continuous, right? The only time is not continuous. The only times not continuous is what? Yep, tan of x, secant of x, cotan of x, cosecant of x, or x on denominator. X on denominator also is not continuous. But remember, you have to pay attention, it's within the interval. So if you say 1 over x between 1 and 10, that's okay. But if a 1 over x between -5 to 5, that's not okay. Does that make sense?
Yes.
Because the not continuous at 0. But if it's not differentiable, so it's not differentiable, it's outside, it's okay. So it has to be within the interval, right? So within the interval, then that's fine. Differentiable, right? So you can understand the function has to be continuous. Now, why do they have to be differentiable in order to this to work? So which one is work? F prime of c is equal to 0. And you say f prime of c equal to 0. So what does that mean? So let's list down the condition. Slope is equal to 0? Yeah, that means there's a horizontal tangent, right? So if I have an A, I have a B. And I have the same output, right? The two same output. One of the easiest function you can build is what? Y equal to x. Well, yeah, that's easy, but there's an easier function than that. It's a number, good. Let's say it's equal to 3, right? So we say at least one c. It turns out every value is f prime of c is equal to 0. It turns out that way. So usually function not going to be a straight line. So, well, if it goes up, it must come back down because fa equal to fb. So it's come back down. Guess what? You're going to have a 1c value here is where your horizontal tangent. So you can have something like this, right? You have 1c. Or you can have a different color. You can have like this. You have 2c. C1, C2. So you got a C1, C2 that's equal to f prime of x equal to 0. But why do they have to be differentiable? What if they're not differentiable? What will happen? So this is not working, right? So not working here. If I draw something like this, even though I have every other condition, I don't have differentiable. I can have like this, and that's A, that's B. what kind of situation I can have not differentiable and rules value doesn't work?
Short term.
A sharp turn. So the easiest sharp turn I can think of is absolute value. Guess what? The slope here is positive. It's not 0. Slope here is negative. It's not 0. Slope by here, it's undefined. So you have to have a differentiable in place. So this is not differentiable. So not differentiable, not differentiable. So rules doesn't work. Does not work. Okay, does not work. Now, why do I say FC is equal to 0? So remember, this 0 are connected. See this 0 here? This help you remember. The rule is when derivative equal to 0, the O I put a different color. Kind of tell you that that's a way to memorize this. Unfortunately, this is one short trick for me to memorize all those theorems on the AP exam. Because, you know, at the end of the day, that week, you're going to be very stressful. You're going to have to memorize all kind of crap for A-push, for economics, for lit, for everything. So you want to try to memorize as much shorthand as possible. And then you don't want to do the thing. And calculus BC is going to be more worse. So I hear you want to find the value of C, which is we already know how to do that yesterday. So sometimes you have to find the value of C on your worksheet. So I'm going to post a homework now, before I forget. I keep on posting the wrong class yesterday. It's driving me crazy.
What? Sure.
So what score did you get on the
Let me get my UD then.
The first time I took it, I had a very bad teacher that the whole year they only teach me derivative. And didn't even teach completely. It teach me how to take derivative of x squared. So I got a 2 on every exam. So then I drive to a different school to learn it better, and then I got a 5. Yeah, but it's good that it
It's
happened.
not as hard as like it's deemed.
No, it's actually pretty easy.
Was it like easier like back in like the 80s and stuff?
It's harder.
It was harder back then?
It's much harder. Yeah, it's a. I will show you a related rate question, and the related question was very hard.
What does DMW
I don't have no time.